Hi everyone, welcome back to my math teaching online again. So in this video, I will show you how to do the antiderivative. This is the second lesson from the first lesson. Let's get right into the question. On my board, we have a derivative function. 2x to the power 3 minus 4x plus 7. And we want to do the antiderivative of this function. So before I get into how to do this, let me remind you about the original question. We're talking about going back, forward, and moving backward. So remember, this is a notation of antiderivative, long as, and we have a function of 2x. And the answer for this is x squared. Let me give you another one. Let's say if we have the question 3x squared. And what is the answer for this? The answer, after we do the integration for this, we will have the answer of x to the power 3. Now, if you look at these two patterns, you will notice that the derivative function have a power of 1. Then after we do integration, we got the power 2. The derivative function have power 2. After we do the integration, we have power 3. So, and this number 2 become 1, number 3 here become 1, and why is like that, right? So remember, I told you moving forward, right? If the operation is adding, if you move forward, let's say you have some number here, then the operation here is adding, right? And that is, you get the answer from here. So now, if you want to form your answer moving backward, if this is adding, so moving backward, we do opposite, which is subtract, so that we get back to the original thing, right? And if moving forward, the operation is multiply, then we move backward, the operation is divide. So that's how it comes from here. So our mathematician developed the formula to find the antiderivative, which is our formula will become, if we want to find the antiderivative of any function, right? So the answer will be x to n plus 1. And let's say you have an a number here. This will be divided by n plus 1. So what is this formula come from? It's come from this idea, this concept, right? Remember, when we do derivative, let's say we're talking about, let's say if we do derivative, right? Derivative. We have x squared, then we bring this down and we have 1 times 2, x, 2 minus 1. That is how we get to 2x, right? So that is when you do derivative. So you see that the derivative formula tells us subtract the power. Now the antiderivative formula tells us adding back to 1, which is going backward. Subtract become adding. Now the derivative formula tells us to multiply whatever the constant number here, multiply with the power. So we get 2x. Then going backward, multiply, so instead of 1 times 2 here, right? Going backward, we divide. So the number 2 here have to divide by the power n plus 1, which is 2. So that's how this formula comes from, right? So I just explained to you the formula. So you can see that the opposite operation show you the formula, right? in derivative, we take away minus 1. In antiderivative, we compensate by adding back to 1. In derivative, we multiply the power with the constant in front, right? This is number 1 in front. Then in antiderivative, we divide instead of multiply, right? So this formula comes from. So why do we have to follow the formula to do this? The answer is in math. The question is not just simple like this, right? The question sometimes have rational function, power, square root, third root, blah, blah, blah. Very complicated. And if mathematicians did not develop the formula for us as a tool for us to use, it's very hard do our computation. So in order to perform our computation more effectively, we use a tool that the mathematician gave us. So if we know the formula is correct and we accept it, onward using it and perform our computational computation in a very easy way. So that's the answer for it. So this formula is very powerful for we do any computation. So let's using this rule, the formula here, to do antiderivative of this function. So this function now, instead of the f prime of x, now will become an original function f of x, right? So let's follow this. So we will take away 1. So this number 2 will divide it by 4. The reason because we add 1 power in here. So x no longer 3 up to power 3 become x to power 4. And we divide it by 4. So what the answer? The answer is 2 over 4 is 1/2 x to power 4. So that is for the first term, right? So let me write the first term down here. So we have 1 over 2 x to the power 4 minus the second term, we do the same, will be 4 divided by 2 x to the power 2. And this is the constant. So the rule here say that if we have a constant, it will add to an x. So 7x plus c. So remember this constant c is because we don't know what happened to the first original function. So let's simplify it one more time because we don't know the initial points, right? So but let's say any antiderivative now, all we're adding with the constant c at the end, okay? So this function is 1/2 x to the power 4 minus 2x to the power 2 plus 7x plus c. So that is the answer for this antiderivative of the function. There will be a lot more adding to it. And you will see the mathematician developed the formula for us to use. So it's nothing wrong to memorize the formula, to be able to use it effectively in mathematics computation. And we call it a mathematical technique, right? So if we don't use a mathematical technique to apply in all the question in math, it's very hard to figure out what is the right answer, what's the correct answer. Anyway, there's a lot more adding to it. Directly right here, Apple, big capital is antiderivative, right? So now, what we're going to do? Remember, this number we have to divide by the power, right? And this is power 2. We add into power 1, it becomes power 3. So divide by n plus 1, which is 3. So that 2 over 3 x to the power 3 minus this is 1. This is going to become x squared, and we're going to divide by 2 plus 7 If you have a 1, it become x. So it's 7 will become 7x, right? So, and don't forget, you still have to add c. But we just don't know what is c here. Now, I'm not going to show you how to find c. It will become to the next, a few next example, right? So right now, just accept this one. So I'm going to give you another question. And another question will be a little bit harder, more complicated. Let's say if you have f prime of x equal square root of x minus 5 over x, adding with 1 over x to the power 3. So this is getting a little bit more complicated, right? How are we going to do this question? I am going to change this, become a rational power, so I can do it more easily. This is the same for now. Adding, just keep everything, no. I'm going to bring this up here, right? So when you bring it up, positive power become negative power. Remember, on this power, remember the n here, remember the rule, n have to be different from minus 1, right? Because if you have minus 1 at 1, you have a power 0, which is not the formula, right? So just this condition, bear in mind, right? So now this will be antiderivative, become a big function, right? Will become f, big capital Fx. We're gonna add 1 in here, right? Remember the rule. And when we add 1, 1/2 add 1 become 3 over 2. So this will be 1 divided by 3 over 2, right? And x here is 3 over 2. However, I'm going to twist this fraction right now. If you have inverse fraction, 1 over this fraction, we can twist the inverse fraction, become 2 over 3 instead of 3 over 2, right? The same like we divide this fraction. So that will become 2 over 3, right here, minus 5 over x. Now, why don't I bring this x up here like this one? The reason, because we have this condition. We say whatever the power n here have to be different from minus 1. And here, you bring it up, you got x to the minus 1. And that not allowed. That's why I don't bring it up. So minus 5 over x, let's follow this. If you have 1 divided by x, it equals ln x. So this obviously equals ln x. However, you have 5, so you have to tie with it, so that becomes 5 ln x. Because this is the same like 5 times with 1 over x, right? And this is just 5 itself, it's just number 5. And you change this become ln x, right? So that is 5 ln x. And this 1 will become minus, adding. We will add 1 in here. So that become minus 2, right? So this number have to divide by 2. And this number, x to power 3 plus 1 become x to power 2, minus 2, sorry. So now this a little bit look ugly, and don't forget to add c at the end, right? So that will be 2 over 3x, 3 over 2, minus 5 ln x. And this will be, now I'm going to bring the 2 down here because that's minus, right? I don't like it. So let me say this become 2 to the x squared, right? When you bring this down, positive negative become positive. So that's, and then add c. That is how the antiderivative of this function look like. Okay? And here we use another rule in here, right? We use that one as well. Okay, so now what else I'm going to show you? going to show you one more question maybe. Okay, so let me get into how we're going to solve the so pretend that we all know about this rule, right? I will upload this file for you, the rule of derivative. Pretend that we already know them. Now we're going to solve another equation. And the question says phi antiderivative, right? Just put a short form for now, okay? DER dot, which is derivative, with initial condition. So we have a function dy over dx, which is the derivative, right? And that derivative is 4x minus 3. And the condition say for a, the condition is x equals 0 and y, they given us y equals 0. Okay, so first we're going to do exactly the same. We're going to integrate dy over dx. And that you also can write like dy integrate dy over dx. You can say dy times dx in here as well. You can bring this up as well. It's like a number 1 in here and you multiply it, right? So that you can do that as well, okay? Dy over dx. But let's replace this by this function right away, okay? So dy over dx here, like the same like the integration of 4x minus 3. But sometimes I use a notation like that. You're not going to use a lot of notation here. Our task right now is to try to find a big capital F, which is the original function, which is we call an antiderivative. Now, in the future, you will see a lot of this in our course, right? When you do area under the curve, do the integration. So the integration is another notation, the same like antiderivative, actually. But you will see it a lot in the another section, okay? So 4x minus 3 and dx. So we're going to integrate this one. Oh, we're going to do antiderivative. Yeah, integrate this one, right? So this will be equal. So let's put in our big capital X, which is the original function, right? After we do the integration, which is antiderivative, this will become 4 divided by 2x squared minus 3x plus c, right? Okay. Now, we're going to substitute because they give us a condition x equals 0. So we're going in this question, in this example, I'm going to show you how to find c, right? Because we are given the initial condition. So x equals 0 and y equals 0. So I'm going to substitute f of 0 in here. So that becomes 2, right? 4 divided by 2, 2. We're going to substitute the x by 0. So this is like 2 times 0 squared minus 3 times 0 plus c. And remember, our y, this is the y function, right? Equal, condition right here, equals 0, right? They told us the y function equals 0. So now we set up this equals 0. So this becomes 0, becomes 0. C actually equals 0. So now we know this function actually have no c. It's just 2x squared minus 3x. And the c becomes 0, so we don't have to write. So that is the antiderivative of this function. And we find out the c value equals 0. Okay, now let's get into the next question, which is Sorry, I have to do. A little bit faster. So that's the question A, and now I'm going to progress to the question B for you. So for B, the function is still the same, right? But the condition now will be changed. They told us the y equal minus 1 and given the x equals 0. So now we're going to say our antiderivative is, for this one, will be equal to 2x squared minus 3x plus c, right? We already do this job here, so we just copy it to here, right? So that is our big function. Now, given this, we're going to find c. So we say f of x is 0. We substitute x by 0. We have 2 times 0 square, follow the expression, minus 3 times 0 plus c. And we will set up this y function equal minus 1, right? This is the given condition. So now this becomes 0, 0 is gone. So now we know c equal minus 1. So our antiderivative function, which is an original function, equal 2x squared minus 3x plus c, but we know c now is minus 1. So that's the answer, okay? So I hope you can see it. Sorry about this come up on my computer. I have to take this off. Okay, so you see it, right? So our original function now, if the question B given y equal minus 1 and x equals 0, which is the initial condition, then this is the original equation we got, okay? Let's say if you have to do another one, I'm going to give you another example, right? Let's say if you have to do another example, which is and sorry about taking time erase my board. So let's say if you have a question C. Now let's do another question. Let's say question 3. So they want to give you S equals 0 and T equals 0. And they said ds over dt, right, equal 9.8t. Okay, so we know this is a ascribe function, right? The s over dt is the same like ascribe. So now we're going to find s, right? And our function is add up t, s respect to t, right? So we're going to do antiderivative of this, which is divide by 2 and t squared and c. So now this s of t will be equal to 4.9. And you will see this number come up very often in physics, right? Which is the 9.8. Here is the gravitational force the force from the earth pull any object. We call it force of gravity, right? So this number very familiar to you. You take physics 11. So 4.9 t squared plus c. Now we're gonna say s equals 0, right? Our function, so this is 0. And the t is 0. So if we substitute in here 0, so we have 4.9 times 0 squared plus c, and that equals 0. So our c is 0. So our position function respect to time is just 4.9 t squared. Okay. So that's how we do it. So let me give you one last example, because I want to end this lesson, and so that you can do the practice exercise I give you if you're taking my course, right? So then let's do another question. Last question. Let's say if given you, so that question 4, s squared of t equals sine t. And we still given this condition, okay, s equals 0 and t equals 0. So s squared of t equals sine t. So st will be equal derivative of sine t. Now, derivative of sine is cos, right? But antiderivative will not be just cos, but will be minus cos t at c equal 0. So I will see here. Now we're going to substitute the t by 0. So at 0 equal minus cos 0 plus c, and the s function equals 0. Now keep in mind cos 0 equal minus 1. So minus 1 plus c equals 0. What does that mean? If you move the c over, minus 1 equal minus c. Change both sides, c equal 1. Right? So now I'm going to continue here, right? So our function would be st equal minus cos of t. Put it back. But now we figure out the c equal 1. So plus 1. So that is the last example I want to show you in this in the lecture. I still have one example, but maybe the video is too long, so just leave it for now. We get back to our antiderivative, which is a little bit more complex in the next question. But then after that, we get right into application of antiderivative, which is application of antiderivative into the motion, which is related a little bit physics, right? And you will see like more interesting stuff coming when we apply the antiderivative into the word problem. So anyway, I hope you enjoy my teaching, my video, and see you in the next video. Thank you for watching. Bye for now, everyone. And if you're on YouTube, so please hit subscribe, support my hard work, and like if you like. It's up to you. But anyway, thank you for watching. Bye for now.